Watch it. So it is asked in gate 94. They are saying that we have process requests like this 300, 25, 125, 50, and at some point in time we have holes like this, and then these are the process, right? And they are saying that if this is the scenario, they are saying that which one are you going to use, either first fit or if you use first fit and best fit, which strategy will using which you will be able to allocate all the processes some memory space. And first thing is, see, whenever they don't say anything, always think that it is variable partitioning. Variable partitioning means dynamic partitioning, which means even though they are showing a partition as present as one hole, in that hole you could put many process if the space permits. Only thing is it is contiguous. You please read the question, you will understand it, right? So anyway, let's solve it. So let's solve the first one with let's see what happens with first fit. So if I go with first fit, what happens is 300 cannot be fit here, therefore the first fit will put 300 here. If 300 is kept here, then what is remaining? 50 is remaining here and 150 is remaining here. Next 25. So 25, where will this be kept? Using first fit, 25 will be kept in this hole, isn't it? 25. And therefore 125 is remaining here. Next 125. So using first fit, 125 will fall here, right? And next is 50, right? So using 50, where can you place 50? So 50 can be placed here, right? So using first fit, all the requirements can be filled that way, right? Now let's see what happens using the best fit. It is 300, so how much? 150 is remaining here and 350 is remaining here, and it is 600, right? Fine. So this is 50 and this is again 300. Okay, so now if we use the best fit, 300 will obviously go here, there is no other choice. 300 will go here, and next 25. So 25, now we have 150 hole and then 50 hole. This hole contains 50 and this hole contains 150. Then the best fit will choose the 50 hole, right? Which means 25 will go in here, right? So 25 will go in here, creating 25 hole here, right? And next 125 will go here, right, creating 25 hole. Here you have 25 and here you have 25 hole. And next the 50 cannot be kept anywhere because of the restriction that it has to be contiguous, right? So using best fit, we cannot satisfy this request, isn't it? So what is the option? This request would be satisfied using first fit but not best fit. The reason is if I use best fit, I am ending up with two holes at different places containing 25k, but I have 50k requirement, I cannot put it there. So this problem is called as external fragmentation. What is external fragmentation? Having space available at two different places, but since they are not contiguous, I will not be able to use it. This is called external fragmentation. And how can you solve it? By using compaction, which means maybe, see, in this question the compaction topic is not given, but if you want to solve it, then you might have to pull all the occupied the process together and the blank spaces at one end. Therefore you will find a contiguous memory which is free, and you can put it there, right? Fine. Now does it mean that first fit is superior to best fit? It doesn't mean that. The reason is for this particular example, one algorithm is showing better, right? One algorithm is able to allocate it and other is not able to allocate it. Maybe for other example, it might not be true. For example, if you try to have the process request as 300k, maybe 50k here, and then 125k and maybe 25k here, just see what happens, right? It is just going to reverse the scenario. Now if you have 50 which is occupied, and then you have 150 which is free, and then we have 300 which is occupied, and then 350 which is free, and then 600 which is occupied. Now if this is the request, this is the order in which requests have come to you, now let's see what happens with first fit. First fit is going to fill 300 here, so 300 will be kept here and 50 will be remaining whole, and then 50, first fit will put 50 here, right? So if 50 is kept here, right, then what is remaining whole? The remaining whole is 100, and the remaining whole here is how much? 50, right? And next one is 125. This 125 cannot be allocated. The reason is, even though we have space, available space of 150, 125 cannot be allocated. Therefore, if the request sequence is like this, your first fit will fail. Therefore, first fit is not superior to best fit, isn't it? It depends on the request in which you are getting, the order in which you are getting the request, the order in which you are allocating the spaces. And the problem is, you don't know what are the future requests, which means you might know that at this point of time, you might say that why don't you sort it in such a way that this order can be feasible. But the problem is, the process will come dynamically. So at this point, I know I have only one process and then one process. I don't know that in future I might get this request, right? Therefore I cannot do anything, right? Fine. And let's see about this in best fit. Let's see what happens with best fit. Using best fit, this one is going to be 50. 50 is occupied. How much? And then 150 is free, right? And then 300 is occupied, and then 350 is free, and then 600 is occupied, right? Now 150 and 300, if this is the request you got, and now let's see how the best fit works. 300 will be kept here, right, completely, and now 50 whole will be present, and then 50 will be kept here because this is the best fit, right? And then 125 will be kept here, and 25 will be remaining, and 25 will be kept here, right? So if this is the sequence, for this first fit will fail and best fit will do well, and if this is the sequence, for this first fit will do and best fit will fail. So depending on the sequences, some algorithm is better than the other one, but anyway first fit is always faster, and first fit is generally used in all the this MLOC and all many applications. First fit is the best one, right? Fine.